of the talk. Okay, so adaptive interventions, these are individually tailored sequences of treatments. The idea is that you want to tailor the first treatment you'd provide someone to how they are now, maybe through genetics. And then if they need an additional treatment, tailor it to how they're doing on their first treatment, whether they're responding well, whether or not maybe they're suffering some side effects, tailor the second treatment to those side effects, and so on. One of the reasons why adaptive interventions are of interest on the clinical side is because they provide a way for us to begin to operationalize clinical practice. And if you're familiar with some of the problems we're having in clinical practice, one big problem is that we run a large number of medical clinical trials in the United States every single year. And these are usually trials of medication A versus medication B, or medication A versus control. This doesn't tell people or help the physicians decide how to use that medication. It just says, if you try medication A, does it look better than control for this time? But it doesn't tell you how to use it, the tactics of using interventions. And that's what adaptive interventions are all about, the tactics of using both medications and behavioral therapies. I list a series of references here. They're all from the field of mental health because that's my interest. However, there has been a number of these, for example, in obesity research, in cancer, and in a variety of areas across the medical field. So what are they? Well, first, I'm going to talk to you about why one would even be interested in adaptive interventions. So I mentioned briefly on the last slide that it involved a sequence of treatments. And these are settings in which you anticipate needing a sequence of treatments to help someone. Now, why would you need a sequence of treatments? Either because there's no one treatment that is universally effective. Maybe one of the best you could expect for is maybe 60% of your people would respond. So immediately, because you have this high heterogeneity in response, you have to anticipate the fact that you might need to consider a second treatment or even a third treatment before someone will do well. Not only that, in many areas of medicine, you can be on a particular medication and then it will just stop working. It may stop working for biological reasons, or it may stop working because the underlying disorder has progressed. Another reason why the treatment may stop working is because it becomes more and more burdensome to you as an individual. You know, it sounds fine to be told, oh, you just need to take one pill in the morning and one pill at night. But when you have to take that for years, that becomes more and more burdensome. And people often lose motivation, hope, and you have to think, well, what are you going to provide to help them gain that motivation, or to move them to a treatment which is more acceptable. In general, in these settings, particularly with chronic disorders, people go through intervals where more treatment is required, interspersed with intervals where less treatment would be okay. And it's when treatment is burdensome, it's always good to think, well, when can I reduce the intensity or the burden of the treatment? When is that possible? All of this type of setting, the setting in which you would use adaptive interventions, are settings in which you're thinking about sequences of decisions, sequences of treatment decisions. One way, I meant to mention on the last slide, one way these adaptive interventions tailor the intervention to the subject or the person is by use of what people call decision rules. The decision rules input information on the patient and output a recommendation. I want to talk to you about one of my favorite adaptive interventions. I really like this one. Sastri's heard it. I think you've heard this one before. I was a consultant on this project. And one of the reasons why I like it is because it has a foot in social science, that is helping people avoid recidivism, and a foot in the health field. So you can see how adaptive interventions can be used in both domains. And this has to do with a drug court program. It was run in Philly. There's even more references. Yes, these slides are going to be on my website. With each slide is a notes page, and you can get the references on the notes pages. Okay, so in this adaptive drug court program, the goal, of course, is to minimize recidivism and also reduce drug use. The way they operationalize it is by actually graduating from the drug court program. And there was a number of requirements each person had to achieve in order to graduate from the program. So what happened in the program is the offenders come in, and they're divided into two groups, high risk and low risk. The high risk offenders, these are people who have antisocial personality disorder, or they've had formal drug abuse treatment. It's this group of people. And then the low risk is the complement. And how do they differ in terms of their treatment? Well, they have the same standard drug abuse counseling. This is a group-based counseling. They meet several times per week. But they differ in the court hearing schedule. So court hearings are an extremely expensive behavioral intervention. So if it is possible to reduce the expense of this behavioral intervention, you want to. So for the people who are low risk, they had as-needed court hearings, and the high risk was biweekly. And then every month thereafter, they're monitored by the staff. And at the end of each month, it's decided, well, this person is doing fine, they're progressing in the drug court program, or they're non-responsive, or they're non-compliant. So non-compliant, what this means is they're not following the rules of the program. One of the rules is to provide a urine screen every week. So if they don't show up for a certain number of urine screens, that's non-compliance. Of course, if they commit another infraction, that's non-compliance. If they don't show up to counseling sessions, a certain number of counseling sessions, that's considered non-compliance. In any of those cases, the court supervision is stepped up. So, for example, if you were in this setting, your court supervision would be stepped up to biweekly court hearings. And then here, it would go to a court-determined disposition. This could mean being disenrolled from the drug court program and being sent to prison. However, okay, so you could be determined to be non-compliant. You could also be determined to be non-responsive. This is someone who's making their best effort. They're showing up at all the counseling sessions. They're providing all the urine screens. They're following the rules. They're not committing infractions, but they're still using drugs. So 2 or more of the drug urine screens are positive. That indicates they need more help. It's not a criminal behavior problem. It's more of a drug abuse problem. And so these people they're moved to what's called intensive case management. Intensive case management involves individual counseling in addition to the group-based counseling. It also involves more help with housing and employment. It's much more intensive than the standard, and it's more expensive as well. So this is an adaptive intervention. We see how the intervention is being adapted, right? Because the whole intervention is the drug court program. It's adapted to how people come in, whether they're high or low risk, and it's adapted to how they progress while they're in treatment. Right now, and in fact, the way this intervention was designed, to a large extent, most of the time when people develop adaptive interventions, they draw on behavioral theory, clinical experience, some biological theories, and expert opinion, and they just formulate the whole program. That's how it's done. So what we're talking about today is how we might use data, how we might use evidence to formulate these types of interventions, these adaptive interventions. So in order to, we want to use evidence to deal with certain questions. And 3 questions that arise over and over again when you're thinking of an adaptive intervention is, what is the best sequence of treatments? What treatment should I provide first? If they don't do well, what treatment should I provide second? On the other hand, if they are doing well, What treatment should I provide second? Maybe I can provide a less burdensome treatment if they are doing well. How long should I try the first treatment before I give up on it and say it's time to move on? These are the tactics of clinical practice. How long do you try that first treatment? How long do we stay on the first treatment before we can consider reducing the burden of that treatment and going on to some sort of maintenance therapy to prevent relapse, for example? And then what information on each patient should you use? What information might you use in informing these decisions? That's what we want to use data. We want to use data to address these types of questions. So how might we collect high quality data to address these kinds of questions? It's via this use of what's called a sequential multiple assignment randomized trial. And the abbreviation is SMART. I didn't make this up, okay, because I am a statistician and I don't think like that. I was collaborating at the time with a behavioral scientist, and she made that up. It's been great, though. It's great. It has really, I'm telling you, if you're a mathematician and you want to really have an impact on science, you need a catchy name. This is absolutely crucial. I know it sounds awful, but it's crucial. And it has really helped. I'll indicate this later on. Okay, so what are these sequential multiple assignment randomized trials? These are multi-stage trials. Each participant moves through stages of treatment, every single participant. Each stage concerns a critical decision that you are trying to investigate. What treatment to provide first, what treatment to provide second, that sort of stage. And every time you have a critical decision you want to investigate, you have a randomization, because randomization is one of the ways that we can investigate what to do, how to make decisions. It's a way to gather best, highest quality evidence. Okay, so I'm going to show you, this trial right now is in the field. It's ongoing in Baltimore at Johns Hopkins. It's a very interesting trial. It's a trial for women who are pregnant who are drug abusers. And the goal here is to have them stay off drugs long enough to give birth, at least to give birth. So the real goal is to prevent the child from suffering from the drug abuse of the mother. The PI, Andre Jones, had developed a very expensive and intensive intervention called reinforcement-based treatment. In this treatment, the participants spend most of the day, every day in the clinic. There's many, many different components having to do with goal setting, feedback. It's extremely intensive and expensive. And what they were finding, and it was very efficacious, you compare it against standard care for the women, and this treatment did much better. The problem was around 40% of the women still didn't do as well. They couldn't stay completely clean. This was disconcerting. Another fact is this is a very expensive treatment. So how are you to think about rolling it out in real life just didn't make a lot of sense. So she wanted to investigate both the options for reducing the intensity and scope of the treatment if the person is doing better, and also options for increasing the intensity and scope of the treatment if it's required. So what happens is the women come in, these are all pregnant women, as I said, and they were drug abusers. And they're assigned to a traditional version of reinforcement-based treatment. This is the usual version, it's intensive, and it has a certain level of scope, versus a reduced version. So the idea here was it could be that some women could start off on a lower level, and then only if indicated would you move them to a higher level of intervention. These are burdensome interventions for these women. Okay. Then at 2 weeks, now you might think, well, why 2 weeks? The concern here, what they had noticed when they had run these studies before, was women who are not going to stay around, they run off really fast. And so they wanted to hit them early catch them early before they could slip back into substance abuse and disappear. So at 2 weeks, by the end of 2 weeks, they know, for example, if the woman has used any drugs within the 2-week period, whether or not she's made all the counseling sessions, these are not counseling sessions, they're like whole days of treatment. Has she shown up for all the days of treatment? So they had a criterion for non-response. So if you were a non-responder and you started off on the traditional reinforcement-based treatment, you were a non-responder, you didn't do well, you were starting to show signs that you would disappear in the near future, you're re-randomized to 2 alternatives. One alternative was, well, maybe you just need to re-engage the person and try the same intensity and scope. That's the traditional RBT. The other alternative was, no, we have to try even harder. Now we're going to have home visits. We're going to make more of an effort to keep you with us. And that was the enhanced RBT. If you were a responder, they always thought, well, maybe you should stay on the same, versus maybe we can reduce the intensity and the scope even further. Reduce the burden on you, reduce the cost. So this trial is currently in progress at this time. In general, the trials, when I talk to clinical scientists about the trials, I usually show them this picture because it's like a template for a trial. Participants come in, they're randomized to treatment A or treatment B. They're monitored for signs of early response or early non-response. If they're early responders, they may be provided some sort of relapse prevention or a lower level monitoring. If they're early non-responders, you might switch treatment, you might augment. These are all tactics. So we often discuss adaptive interventions and these SMART trials within the context of this template. I just wanted to indicate one adaptive intervention to make sure we're all on the same page about what an adaptive intervention is. One adaptive intervention is outlined in blue here. An adaptive intervention has to provide something for you no matter what. So it provides treatment A first. If you're a non-responder, it augments with treatment D. If you're a responder, it provides relapse prevention. So an adaptive intervention has to provide something for both responders and non-responders. Actually, we could go through here and we could find 8 different adaptive interventions in this study. Now, the individualization or the tailoring of these 8 adaptive interventions is pretty crude. The only tailoring or individualization of these 8 are based on signs of early response, early non-response. But at the end of this talk, I'll describe to you data analyses that allow you to investigate a more deeper type of individualization. But we'll get to that shortly. I wanted to talk to you about several why one would be interested in these kind of trials. And when I first started in this area, I thought the thing that came to my mind is what I'll do is for every critical decision, I'll run a separate trial. And this was really attractive to me because if you go across the clinical field, we've already run trials on initial treatments. And often we've run trials for non-responders. And we've run relapse prevention trials for responders. We've done a lot of that. So maybe I can piece all this together and produce an adaptive intervention. And these next couple of slides are explaining why this might not be the best. This is not the best idea, not the best approach. So if I were going to use that approach, I would look at my trials of initial treatments. I'd choose the best performing initial treatment. Then I'd look at my trial for non-responders. I'd choose the best option for non-responders. And then I'd look at my trials for responders, and I'd choose my best maintenance therapy. And I'd be done. Everything would be set. Okay, the first reason why you would want to look at you'd want a trial in which individuals move through the sequences of treatments as opposed to separate trials, separate clinical trials, is because of positive synergies. And in my mind, one of the areas that makes the clearest case for positive synergies is with counseling, face-to-face counseling, and, for example, low-level telephone counseling. Often face-to-face counseling has a much more durable effect if it's followed by a low-level telephone counseling that reminds the person to utilize all the behavior techniques that they have developed during the face-to-face counseling. Not only that, if I think about telephone counseling, usually to have any type of effect, for counseling to have an effect, there has to be this therapeutic bond between the counselor and the participant. And it's very hard to obtain that in telephone counseling because it's not face-to-face. And so often telephone counseling is more effective if it's preceded by face-to-face counseling. So this is a positive synergy between two different types of treatment, one that might be a maintenance therapy and one that might be an initial treatment. You would see this in a variety of behavior change areas. Negative synergies, unfortunately, they occur all over the time, and they're much more, they hit you right in the head. Here's an example of a negative synergy. Well, first so what is a negative synergy? Treatment A, you're comparing treatment A and treatment B. Treatment A looks fantastic. It produces many more early responders than treatment B. But unfortunately, treatment A, if you don't respond, is associated with certain side effects. And if you get those side effects, a whole host of other drugs are no longer possible for you. This happens with antipsychotics. There are certain antipsychotics that if they don't work for you, they can produce movement disorders. And once you get one of these movement disorders, you have it forever. And a whole host of other drugs are no longer possible for you. So even though an antipsychotic may be very effective initially, if it produces a high rate of these movement disorders, you're not going to want to use it at the beginning. This also happens in cancer. I have colleagues at MD Anderson, and they had run trials of this type, and they noticed that so let's think of chemotherapy. Often with chemotherapy, in order to cure you, it has to really, they're very toxic. Chemotherapies are extremely toxic. So if you have two chemotherapies you're comparing, one which produces a high level of response compared to the other, but the one that produces a high level of response is also so toxic, which is usually the case, that if you don't respond, your body is damaged so much that you cannot be provided another chemotherapy. In that case, if you compare a sequence of treatments, one beginning with what appears to be the more effective initial chemotherapy versus another sequence of chemotherapies, the other sequence beginning with what appears to be a less effective, initially effective chemotherapy, people on the second sequence do better overall because they're more resilient to be able to take advantage of subsequent treatment. So this is a negative synergy. Prescriptive effects also occur. I find this one quite interesting, actually. So you may have two treatments, treatment A and treatment B. They're, say, essentially the same level of effectiveness, but one elicits certain symptoms that allow you to better match the subsequent treatment. The example in my mind when I think of this is if it's a behavior change setting and I have one treatment which doesn't have a lot of emphasis on adherence and a lot of emphasis on motivation versus another treatment that spends a lot of time and effort on adherence and motivation. The first treatment may not do as well initially, but what it'll do is it'll identify the people who really need a lot more help with their motivation and their adherence, and thus allows you to match a subsequent treatment to those people more effectively. Whereas the first treatment would be more intensive, it would have tons of things, but you wouldn't know who really needed those more intensive aspects of the treatment with the treatment that it included all the motivational aspects to it initially. So having a less intensive, less inclusive treatment initially is maybe useful in identifying who will really truly need the more intensive aspects of the treatment. That's a prescriptive effect. And then the last one I've begun to appreciate more and more as time has gone on. Again, what are we doing? We're talking about why you would want to look at a trial where participants move through the stages of treatment rather than separate trials for each stage. Okay, so this is called a sample selection effect. And the first way I used to think about this was in most trials today, you're assigned to treatment A versus, say, control. And if you, say, for 6 months, many of the trials I know of are 6-month trials. And if you start to do poorly, it's just too bad. There's no allowance within the parameters of the trial for you to get onto another treatment. You just have to walk off. You have to refuse the treatment and walk off. With these trials, though, if you start to do poorly, you know ahead of time something's going to be done. On the other hand, if you do really well, you know you may be moved to a less burdensome treatment. So subjects who enroll in the trial may be quite different. Another example that's, I think, even more cogent and really made things very clear to me was I was talking to a colleague at UPenn. He's a substance abuse researcher, and he had run a number of these non-responder trials. He had these great treatments for non-responders. These were cocaine abusers or alcoholism, either one. He loved his treatments for non-responders. He was able to convert a lot of non-responders to responders. Okay, so then he decides he's going to run one of these trials, one of these sequential multiple assignment randomized trials. So he starts it off, and he gets all these non-responders, and he discovers that a good fraction of them have no interest in being treated anymore. What had happened? In his non-responder trials, he was only recruiting motivated non-responders. He wasn't recruiting the ordinary guy who's not responding. And what he learned was he needs a therapy or some sort of intervention that helps these people re-engage, them back into treatment, gets them to now go into a secondary treatment because they haven't done well. But he wouldn't have realized that otherwise because his trials were just going along beautifully. Unbeknownst to him, he was just recruiting a very select group of people, not your usual non-responder. Okay, so the point here is if you're interested in comparing or assessing the effects of treatments that are part of a sequence, it's good to look at it as part of the sequence as opposed to looking at each treatment as if it's a standalone treatment and then trying to patch them together. A lot of times when I first started working in this area, people were very skeptical. When I say people, I mean statisticians. Statisticians, okay, so maybe they're people, maybe they're not, but nonetheless, they were very skeptical. And it turns out, with no insight by the statistical community, clinicians had already started running these kinds of trials because they recognized that they had to do something for these non-responders. They had to do something for the responders. And in particular, Katie, it's one of the most famous mental health trials is of this type, and it was run without, at the time it was run, there was no expertise in the statistical community to deal with these types of trials. So the clinicians were way ahead of everyone else. Subsequent to this, there have been a whole variety of trials. I just list 4 because I was involved in them. Actually, we've started collecting them. This website has a subset of trials. I personally know of at least 20 right now. And this year, NIH has 4 different calls for proposals for clinical trials calling for this trial design. And it's because of the problems, the desire to find good treatments for chronic disorders, because those tend to be sequences of treatments. Okay, so we're going to go to some principles for these trials. This is our template. So when I first start talking to people about these trials, mainly clinicians, they get really, if they like it, they get really excited, and they want to do what I would want to do. They want to say, well, let's consider all the treatment options for our adhering non-responders. That is, non-responders who adhere to the medication, but nonetheless they are not responding. And then I'll consider a separate group of interventions for my non-adhering people who are non-responders. And then I'll consider a separate group of interventions for my responders who have good social support. And then I'll consider a separate group of blah, blah, blah. And the point here is that the design of the trial, when you design the trial, you're deciding what you know and what you don't know. And if you use non-response as part of the design of the trial, which was in our template, you're saying, I know that non-responders need to be provided different treatments from responders. You know that a priori. So that's built, non-response is built into the design of the trial. However, it's not always clear that non-adherers who are non-responders should be provided different treatments from adherers who are non-responders. Maybe the reason why they're not adhering is because they're not responding. So in that case, you want to discover that you need to treat non-adherers differently from adherers. Let's just keep it simple. Only put into the design of the trial the things you know have to be there, like we have to treat responders differently from non-responders. And then, of course, you want to collect information like adherence level, like side effects, social support, and so on, to see whether or not the treatment should be tailored to these other characteristics. And then you want to power. So what does power this study mean? Power means decide how many people you're going to recruit into your trial. You want to always power the study so that you have confidence that you can address a particular question, and that's called your primary hypothesis. And then you could, usually, if you're a clinician, this is where all the excitement is, the secondary analyses. So the secondary analyses, and I'll give you an example of one, they involve greater individualization. Okay, what we're going to do, I'm just going to show you two ways to size the trial, that is, decide how many people are in the trial, and then we're going to go to the secondary analysis, because that is indeed where the excitement is. So one way to size the trial is to say, I'm going to compare all adaptive interventions beginning with treatment A versus all adaptive interventions beginning with treatment B. It's just a two-arm comparison, and that's the red versus the blue people. Everybody who follows a red path with everybody who follows a blue path. And if you're familiar, I don't know how many of you might be familiar with clinical trials, but this is exactly the way most clinical trials are powered, are sized. Another way, and I've been involved in a number of trials who've done this, they were really interested in what are you going to do for your non-responders. So they recruit sufficient number of people, that is, size the trial, so that they have enough people to decide between the two alternatives for non-responders. And in that case, that's a comparison, again, of the red people. There's two ways people can have a switch, and there's two ways people can have an augment. And again, it's a two-arm comparison here as well. What the message I'm trying to communicate is that a lot of the statistical aspects of these trials are pretty much the same as a standard clinical trial, randomized trial. I'm going to skip the sample size calculations, and I'm going to go on to the part which most clinicians and most statisticians find most interesting. And that's how you can look at the data to explore whether or not more individualization is warranted or might be warranted. This trial is over. It was a trial of little kids who have ADHD. It started at the beginning of the school year and ended then at 8 months later at the end of the school year. And what happened was at the beginning, all the kids have been diagnosed with ADHD. They come into the school year at the beginning, and they're either started with a low-intensity behavioral therapy. This therapy is actually training for the parents, training for the teacher, and some training for the child. So there's a lot of teacher and parent training going on here, okay? I don't want to mislead you. It's not just child. Or they're provided a low-dose medication. In this case, it was Ritalin. And then beginning at 2 months and monthly thereafter, they're assessed for problems in the classroom. And there was an operationalized definition of non-response. It had to do with misbehavior in the classroom. So beginning at 2 months and monthly thereafter, they're assessed for non-response. If they're doing okay, they just stay on the same, what's working, they just stay on it for the remainder of the school year. If they don't do well, they start to have problems in the classroom, they're randomized to one of two tactics. Augment, if you started with the behavioral modification, augment with med, versus intensify the behavioral modification, retrain, do more retraining. If they started with med, they could intensify the medication, that is up the dose, provide evening meds, or augment with the behavioral modification. Now, why was this trial of interest? It was funded by IES. There's enormous controversy in the scientific community about using medication for ADHD. Ritalin and all of these medications, they're associated with very short stature because the kids won't eat. Yet the behavioral modification, this is intensive. It costs a lot of money. It's not easy. It's not like just giving your child a pill. So the American Psychological Association recommends that you start with behavioral modification first and only go to medication if it doesn't work. The American Pediatric Association suggests that you start with the medication and only use behavioral modification if it doesn't work. So leading organizations in our society have differences of opinion, and they wanted to run this trial to see how this would play out. Okay, so what are we going to be doing? Okay, we're not going to talk about primary analyses or any of the kinds of analyses that one would do we're going to talk about greater individualization, exploring greater individualization. What do I mean? Producing or constructing an adaptive intervention that permits using other characteristics of the individual to choose which treatment. Okay? That's what we're going to talk about. Well, it turns out there's this method. Okay, we're talking about sequential decision making, right? Because we're a sequence of treatments. We have to make decisions about the first treatment and then the second treatment if they're not responding. There's a method in computer science called Q-learning. Right away, you should say you know it's in computer science because it has learning on it. All computer science methods have learning in the title if you're familiar with that. And this is a machine learning method. It's one of the machine learning methods. And Q means quality of treatment. That's why it's called Q. We're going to learn the quality of the treatment. And what it is, if it's not presented in this way, but what it is, if you reverse engineer the method, it's an extension of regression to sequential decisions. Now, I think some of y'all may be familiar with dynamic programming. Right. You're going to see dynamic program. It's going to see, that's what's going on here. I'm not going to state that, but that's what's going on. Like I said, it's an extension regression to sequential treatments. This regression, it produces a proposal for an adaptive intervention. And of course, you would have to evaluate that adaptive intervention in a future trial. You can't just pretend like it's the one you should go and implement in real life. You're just constructing an intervention. You're not confirming that it's best. Okay, so let's think about the stage 1. These are all the little kids. They come in at the beginning of the school year. They're either provided low intensity behavioral modification or low dose Ritalin. We have some data on them. We have their baseline school performance. This is school performance from the prior year. We have whether or not they were medicated for ADHD in the prior year, and whether or not they have oppositional defiant disorder. Yes, no. This is a particular interest. Once someone has been medicated, there is some thought that they will tend to, it's an indicator of severity. They may be more severely impacted. They're going to either be an early responder or not. R is 1 if they're an early responder, 0 otherwise. And we're going to code our treatment as 1 if they're on the behavioral modification, -1 if they're on the med. Stage 1, it involves all kids because all of the kids got randomized to B-mod versus med. Stage 2 data. Now, stage 2, you only get into stage 2 if you're a non-responder. So it's only children who do not respond in stage 1. We have our end of school year performance. For the purposes of this clarity here, we chose just one outcome at the end of the school year. It was a measure of how well you were performing in the classroom. We have our treatment. We're going to either intensify your current treatment or augment your current treatment. 1 is intensify. It's coded 1 if intensify. We have some information on you. We have how fast you started to not respond. Some kids, by month 2, they're already not responding. They never did respond, actually. Other kids go almost the whole school year before they stop doing well. And we also have a measure of how adherent the child, the family pair were in terms of both either the medication, if they were on medication, or the B-mod, if they were assigned to B-mod. The clinician who was involved in this, he was really for including the meds. From the prior slide, he really wanted to include this because it was well known that medication, this is a proxy for greater severity. I, on the other hand, wanted to look at adherence as a potential variable because I, as a statistician, am often given data sets in which people stopped adhering, and somehow I'm supposed to fix that. And to me, adherence is actually a sign that you need to alter the treatment. So I was thinking maybe adherence would be a variable that would indicate whether or not we should intensify or augment treatment. Okay, so how are we going to, as I said, Q-learning is an extension of regression to multiple decisions. How do we conduct it? We go backwards in time. That's the dynamic programming aspect. So we conduct our stage 2 regression first. And the reason why we have to do that is in order to conduct a stage 1 regression, we need an outcome, a dependent variable for the stage 1 regression. And that dependent variable is constructed in the stage 2 regression. The stage 1 dependent variable in our regression is the predictor of our outcome if the person received their best treatment in stage 2. So we have to construct this predictor. So we have to do the stage 2 regression, then we get to construct the predictor, then we get to do the stage 1. Okay, so we're going to do stage 2 first. And this is just for non-responding children because they're the only ones that move to stage 2 in this particular study. Everything, I think I just told you all of this. I had a slide that was exactly this slide before. So I do a regression, I'm a typical statistician, I get me a regression, there you see it, alphas and betas. I put these in small font so you would ignore them. I just want to focus on this one. A2 is 1 if it was intensify, -1 if augment. These are regression coefficients. This was the indicator of stage 1 treatment. This is whether or not you were adherent or not. 1 if you were adherent, 0 otherwise. This term in parentheses, if it's positive and A2 is positive, then we get a high predicted Y, high school performance, predicted school performance at the end of the year. If A2 is negative, the only way we can get a higher predicted school performance is if this linear combination is negative. So when the linear combination is positive, we're going to want to choose an A2 equal 1, that is, intensify. When this linear combination is negative, we're going to want to choose an A2 equal -1, that is, augment. And that's related to this clinical question. Does the best stage 2 tactic, intensify versus augment, differ by whether or not the child-family pair was adherent? And so we estimate those betas. Here they are. These is the 3 betas. And you see that the decision rule is in this, you can write it in this technical way, or you can write it in terms of this box, which makes it very clear. The coefficient of adherence is very large compared to all the other coefficients. And what does that mean? If they're adherent, you intensify. It doesn't matter what their initial treatment was, you should intensify if they're adherent. If they're not adherent, augment. You switch treatment. This makes perfect sense. The clinician thought this was great. Okay, so now we're ready to go to stage 1. So we got to form our dependent variable. The variable we're going to use is our outcome variable in stage 1 for our stage 1 regression. It's our predicted end of school year performance under optimal stage 2 treatment. Okay, so what does this mean? It's the predicted end of school year performance for if a child was adherent, that means you intensify. If they were not adherent, that means you augment. That's under that regime. And we're going to have these kind of covariates in there. So again, I wrote my regression equation and had a larger font for the part. Oh, wait, I'm in the wrong. I think I'm in the wrong. Oh, I know what I remember. Okay, I have to tell you how I got my dependent variable. I wanted to give you a slide on that. Since this is a stage 2 regression, how do I form the dependent variable? I construct a y-hat from this stage 2 regression. It's right here. So let's think about this. It's the first terms, my estimated terms up here. And then if this is positive, I want to choose A2 equal 1. If this is negative, I'm going to choose A2 equal -1. I went through that before. That's essentially the same as putting absolute value. So that's my y-hat. So for the non-responders, I put this. And for my responders, I just use their end of school year outcome. So that's going to be the y that I'm going to use in my stage 1 regression. Here's my regression. Here's 1 if behavioral modification, -1 if medication. And here's my coefficient. So if this is positive, I want to choose behavioral modification. If this is negative, this linear combination is negative, I want to choose medication. And that corresponds to this scientific question, does the best initial treatment differ by whether a child was medicated for ADHD in the prior year? And the clinician anticipated that this would be an important variable. Okay, so we run it and we get, there's our regression coefficients, and you see indeed the clinician was right. If they had received medication in the prior year, provide med. If they had not received medication in the prior year, provide behavioral modification. Okay, this sounds all fine and good. Now, this treatment I shouldn't have called it a treatment policy. I should have called it an adaptive intervention. This adaptive intervention is very decisive. What is it? What was our adaptive intervention now? It was start off with meds if they had received meds before. If they hadn't received meds before, start off with behavioral modification. If they're a non-responder and adherent, intensify. If they're a non-responder and non-adherent, augment. We just constructed our adaptive intervention by all these regressions. That's what we did. It's quite decisive. I mean, I just told you exactly what you should do. the data set only had 138 children. Actually, it was supposed to be 150, but a group left within a month at the beginning of the trial. Is there sufficient evidence to warrant me being so confident, being so decisive when I present these results? Would a similar trial obtain a similar adaptive intervention? And there's really strong opinions in the field of ADHD as to whether or not you should provide behavioral modification versus medication. So one solution to deal with this is to use confidence intervals. Confidence intervals, of course, will reflect the fact that we only had 138 children in this trial. They'll reflect the level of noise in the data. So I do that on the next slide. It turns out that second stage regression was highly significant. Adherence just, yeah. So let me go through this. A positive treatment effect means intensify. So look at the first two top rows. The confidence interval contains 0. It contains both negative and positive values. There's no evidence if you're adherent for either one. You could choose either one. We don't have clear evidence. However, if you're non-adherent, both confidence intervals are completely negative. Makes perfect sense. You've got to switch. You've got to augment. Don't just intensify. That's what this indicates. Okay, let's go to stage 1. Here, so to get these confidence intervals involved exciting statistics, but I won't tell you about that. Here's the confidence interval. If a child had been medicated the prior year, so we're looking for, well, this one contains 0. So a positive treatment effect means go for behavioral modification, but here we have both negative and positive potential values for our treatment effect, so we can't really say anything. Then we go to this confidence interval. Here, this confidence interval also has both negative and positive values. So you would think, oh, well, you really can't say anything. We presented this to the clinician. Now, okay, so here comes, please, I feel like this is appropriate, what I'm fixing to do. Some may disagree. I present this data evidence. This is evidence from the data. The clinician and I then decide what are we going to suggest should be tested in another trial. The clinician looks at this and says, look, I believe that if a child hadn't been medicated before, they should start on behavioral modification. And this confidence interval is almost all in the positive range. So we're going to recommend behavioral modification. Okay. So here's what we recommended. If medication was not used in the prior year, then begin with behavioral modification. See, this is where the clinician introduced his opinion into it, but he had some evidence. It wasn't like the data evidence was totally not there. Else, select either B-mod or med. So a child who had received medication before, there's no evidence one way or the other. If the child is non-responsive and non-adherent, augment. If the child is non-responsive and adherent, then you get to choose whichever one is appropriate, because there's no evidence to choose one over the other. Okay, so I just I showed you how you might use this data to investigate further individualization. Where are we going? And this is the area that I'm really excited about. I spend all my time on now, and that's where we provide behavioral interventions using wearable devices. These are sequential decision-making problems. I'm involved in one study now. This is again in drug abuse because that is my interest. These are people who are trying to recover. They were in jail for a substance abuse-related crime. They're clean now. They're out of jail, and they're trying to stay clean. And they're carrying around cell phones. And every time their lives are they're not like, they have pretty stressful lives. And every time they feel a lot of stress, they can go to the cell phone, and it has different kinds of little tips for dealing with the stress. meditation ideas, ideas for listening to music that the person likes, ideas for reaching out to your social network, sending automatic texts to friends. Well, in the pilot study, they're accessing the mobile phone around 31 times per day over I think it was a 2-month period. So how many stages are we talking about? 31 stages of treatment per day over a 2-month period. The investigator wants to run this for 6 months. So now we're looking at how do you develop what we would call a just-in-time adaptive intervention. An adaptive intervention that provides treatment. It's a behavioral intervention that provides treatment in the context of the person at the time they need it, up to as many times per day as they request help. And that's what we're doing right now. We'll see how it goes in a couple of years. Yeah, that's it. That's the end.